Okay, let's start the notes on section 6.5. So our objective here is to be able to solve rational equations. So one method you have for solving equations with ratios is to cross multiply. So we're going to do that for the first two problems. This method can work if you have one ratio equal to another ratio. So just like you do when you only have number values in the numerator and denominator, you cross multiply. So multiply across the diagonals. So x times x is x squared. And then 3 times x plus 6 is the other side. And now we simplify. So x squared equals, distribute the 3. So that would be 3x plus 18. And now we have terms on both sides, but it looks like it's going to be a quadratic. So I'm going to move all of my terms to the left, just because I feel like it's easier to have my x squared term have a positive coefficient. So we have x squared minus 3x minus 18 equals 0 on the right. So now I have a quadratic equal to 0. So factoring would be a good technique. So this factors into, let's see. 3 and 6. So it's going to be plus 3 minus 6. So the zero product property says that either x is equal to negative 3 or x is equal to positive 6. So those are possibly my answers. But you should go back and check if there were any domain restrictions, because if you get an answer value that's a value that you can't have as a solution, then you have to exclude it or throw it out. So my domain restrictions where x cannot equal 6 and x cannot equal 0. This negative 6 would make, negative 6. Negative 6 would make this denominator 0, and 0 would make that denominator 0. Neither one of these is in the restricted values, so these are my two solutions. So I'm done with that one. All right, next problem. Again, I have a ratio equal to a ratio, so I can cross multiply. So negative 4 times 1 is equal to x plus 1 times x plus 6. Negative 4 times 1 is negative 4. When I multiply this out, I get x squared plus 7x plus 6. Again, I have a quadratic, so if I move everything to the same side, I get 0 equals x squared plus 7x plus 10. And hopefully this factors. So it looks to me like it's x plus 2 times x plus 5. So that gives me x equals negative 2 and x equals negative 5 as my two solutions. And let me go back and check if that's an issue with my domain restrictions. Over here, I have a negative 4 in the denominator. That does not give me a value that makes it 0. Negative 4 never equals 0. Here I have an x plus 6 in the denominator. That tells me that x cannot equal negative 6. So that's fine. Neither of these is a negative 6, so those are my solutions. So I'm done with that problem. Now let's move to this one. This is not one ratio equal to another ratio because I have subtraction of fractions over here. So I have two choices. I could make a common denominator and then subtract the fractions, and that's fine. But I'm going to remind you that you know a shortcut, and I'm going to always do it using the shortcut. So remember when you had an equation a few months ago, we practiced these, where you were adding and subtracting an equation with fractions. You can get rid of all the denominators at once by finding out what the common denominator is and then multiplying every term by that common denominator. And what that does is allow you to get rid of all the denominators in one step. So the common denominator, in this case, I have a 2 and an x in the denominator, so my common denominator would be 2x. So again, I'm going to multiply every term by the common denominator. So I'm going to multiply by 2x, by 2x, by 2x, and I'm multiplying by it. I'm not making it be the common denominator. So in future, I'm going to simplify when it's right like this, but a couple of times I'll write it out. So x over 2 times 2x looks like this. You can put a 1 on the bottom. Minus 10 over x times 2x, you can write a 1 on the bottom, equals 4 times 2x. I don't need these to look like fractions because there's no denominator anyway. So I don't feel a need to put 1s underneath. And now I'm going to simplify everything. So I did this again, not to get a common denominator, but so that things will cancel and I will not have denominators. So I can cross simplify. 2 divided by 2 is 1. That leaves me with x times x, which is x squared. X divided by x is 1. So that leaves me with negative 10 times 2 equals 4 times 2x, which is 8x. So all in one step, I got rid of all the fractions. And now it's a simple quadratic. So I'm going to move all my terms to the same side. So x squared minus 8x minus 20 equals 0. And this factors. And it factors into x minus 10 times x plus 2. So that gives me my two solutions of x equals positive 10 and x equals negative 2. Now let's check the domain restrictions just in case I got a solution that couldn't work in my original equation. I have a denominator of 2, that's never going to be 0. I have a denominator of x, so x cannot equal 0. I don't have a denominator there. So x cannot equal 0. These are not 0, so that's okay. All right, move to the other side. Last problem. So I need to find a common denominator if I'm going to use the same technique. And then I can multiply every term by the common denominator and end up with an expression that doesn't have any denominators. So I have an x minus 2 and an x minus 4, and then an expression that's not fully factored. So I'm going to factor that first. So this denominator factors to x minus 4 times x minus 2. Now I'm going to copy my whole expression. So I have an x minus 2, an x minus 4, and then I have an x minus 2 and an x minus 4 in another denominator. So my common denominator would be x minus 2 times x minus 4. And again, I'm not trying to make them all have the same denominator. I'm using this technique where we multiply by the common denominator on every term, every single one, not over itself, just multiplying. So this is where I'm writing out the step that I'm going to do. And then below I will write it out so we can simplify easily. So I multiply every term by the common denominator. Now, if I write this out so we can see it all, that gives me x over x plus 2 times x minus 2 times x minus 4. I can put it over 1 plus, now I'm on this term here, 3 over x minus 4 times x minus 2 times x minus 4. Put it over 1 equals 6 over, and I know this one already has the common denominator, but remember, I'm not trying to get a common denominator. I'm multiplying every term by the common denominator. So x minus 2 times x minus 4. You can put it over 1 if you like. Okay, now I can cross. That was a minus. That was always a minus. You can cross simplify before you multiply. X minus 2 divided by x minus 2 is 1. So this simplifies to x times x minus 4. X minus 4 divided by x minus 4 simplifies to 1. So this leaves me with 3 times x minus 2. And here, x minus 2 cancels with x minus 2, and x minus 4 cancels with x minus 4. So that leaves me with a 6. So I don't have any denominators, so now I'm just going to simplify this and hopefully solve. So if I distribute the x, I get x squared minus 4x, distribute the 3, 3x minus 6 equals 6. I'm going to subtract my 6 from both sides, and I'm moving over here because I ran out of space. So that gives me x squared minus 4x plus 3x is minus 1x, minus 6 is minus 12. And if I want to solve, I'm hoping that this factors. So let me try x minus 4 times x plus 3. So this gives me x is 4 and x is negative 3. So those are my solutions. And now I should go back and check if any of my domain restrictions are going to disallow those. So I've sort of run out of space here, but here I can see. My domain restrictions tell me that x cannot equal 2 and x cannot equal 4, and then I have a repeat. So notice my domain restrictions are x cannot equal 2, I don't have a 2, x cannot equal 4. So this is not actually a solution, because if I plugged 4 back into the original function, I would be dividing by 0, and that does not give us a real answer. So I really only get the one answer, which is x equals negative 3. That is the end.